Today we'll be covering the empirical and molecular formula for a compound and then further looking at how it helps us in calculations. So firstly, the molecular formula gives us the number of moles of each element within a compound. For example, if the molecular formula for water is H2O. Through the molecular formula for water, we know for every 1 mole of water, we have 2 moles of hydrogen and 1 mole of oxygen. So that's what the molecular formula tells. It tells the number of moles of each element within a compound itself. On the other hand, the empirical formula tells the ratio of moles. For example, we take the compound C4H8. Of this compound, if we look at this as maybe its molecular mass, in this we know that there are, for every 4 carbon moles, there are 8 hydrogen moles. However, for the empirical formula, we want to know the ratio only. So we can easily divide 8 by 4 and the answer is 2. Therefore, we know for every 1 carbon atom, carbon mole, there will be 2 hydrogen moles, because the hydrogen moles are twice that of the carbon moles. Thus, the empirical formula will be CH2 H18. In this, the empirical formula then becomes CH3, because if you divide it by 6, for every 3 moles of hydrogen, there's going to be 1 mole of carbon. This is not the actual formula, but it's only a ratio of the moles itself. Now let's look at a sample question. The question states a compound X has an empirical formula C4H9. So for every 4 carbon at a mole, 4 moles of carbon, there's 9 moles of hydrogen, and its molecular mass is 114 grams. Based on the information, the molecular formula of compound X will be. So we only know the ratio of the substances, we don't know the actual formula itself. So firstly, we're going to calculate the mass of C4H9, which is basically 12 into 4, because the AR for carbon is 12, plus 9 into 1, because the AR for hydrogen is 9, which gives a total of 57. If we divide the molecular mass 114 by 57, we get a ratio of 2, because the actual substance itself should have a mass of 114. However, the empirical formula right now only has a mass of 57. So we know that the difference in ratio is by the factor of 2. Once we know by dividing the actual amount or actual mass by the mass of the empirical formula, we then know the factor of the ratios. So in this case, we knew that it is 2. Thus, the actual compound itself will be 2 times into C4H9, which is for C4, 4 into 2 will become 8. For H9, 9 into 2 will become 18. Therefore, the answer to this question would be C8H18. In order to check our answer and whether it's correct or not, we can even calculate the molecular mass of C8H18 as well. So 12 into 8 plus 1 into 18 should be equal to 114 as well, in order to confirm our answer. That's all.